Hi, I'm Yannis Roussos, the product manager of the memory group, and I'd like to take you through what we're planning to achieve in GitLab 15.2, which is scheduled to be released on July 22nd of 2022. So our first top priority for 15.2 is investigating the Puma long-term memory use. Puma is the web server that we are using in GitLab. So we have observed that the memory of the Puma servers, the Puma pods, keeps on growing when they are not restarted. And this is more evident during weekends when we don't do deployments, because during deployments, of course, the pods are restarted and the memory is cleared. But during weekends, we can see, and this is the blue line, the memory keep on increasing. This is in contrast to the yellow line, which are the Sidekick servers. Sidekick is the way we run background jobs in GitLab, which is pretty much flat, and that's what we would expect to happen. So this is a clear indication that we have a potential runaway memory issue. And during 50.1, we investigated this problem, and our investigation has generated multiple findings and has led us to 3 separate paths that we want to keep on working during 50.2. So the first one is, of course, the reason why we started this initiative. We want to find the origin of the growth of the growing memory use of Puma when the pods are not restarted and fix it. So we believe that the primary driver is heap fragmentation, but we're not 100% sure that it's the only driver. So we want to make sure that our assumption is correct and figure out ways to address it. The second path is we want to add ways to gather more data from production servers, increase some visibility to those problems, and allow us to diagnose these and similar issues. And the main thing is to add a Ruby heap fragmentation metric. As I already said, we have found that the increase in Puma memory is primarily due to Ruby heap fragmentation. That means that the number of non-empty heap pages keeps on increasing over time, and that memory can never be returned to the operating system. So we want to add metrics and expose them to Prometheus so that we can use them to further investigate and analyze this problem. The third part that we want to work on is to decide how to deal with resource allocation on various environments. So in GitLab, we have what we call the Puma worker killer. This is a piece of Ruby code that runs in the background as a thread, which reads worker processes if they run over a given memory budget. So while we were running this investigation, first of all, we realized that this was not running correctly in GitLab.com due to a configuration bug. So we fixed that, but while doing so, we started a larger discussion. Does it even make sense to run this type of killers in a resource control environment like Kubernetes? So in Kubernetes, we define container and pod resource budgets anyway through Kubernetes. So should we turn it off and allow Kubernetes to do its job? And this is true for the Puma worker killer, and we have a similar issue discussing about the Sidekick worker killer. There are a few pros and cons, and we're going to keep the discussion and make a decision during 50.2. Finally, we want to make sure and make a decision on how to set resource limits on all other environments. So, for example, on Omnibus. So, for example, we have a max memory that each Puma worker can use. And those limits, most of the times we define them, those are hard-coded. So they have a default and we set it and that's it. And we set those limits using our reference architectures and trying to take to cover most cases, but not all environments are the same. So sometimes those limits can be too low, it can cause too many problems, and they have caused issues with some GitLab instances in the past where the memory killer keeps on killing Puma workers too often, and that's something we don't want to happen. So we want to discuss how to dynamically set those limits instead of just increasing them, depending on the environment that each GitLab instance runs into. The second priority is to support the effort for FIPS compliance in GitLab. This is an initiative that we're running throughout the whole GitLab for a few milestones now. And the core request there is that all communications should be secure. And during 15.0 and 15.1, both the memory group and other groups have addressed a lot of of those cases. The last thing that remains for us is to add TLS security for the dedicated metric servers. So those are the metrics endpoints that are scrapped by Prometheus to send all the metrics. So we need to add support for TLS. There are two types of metrics exporters. The ones that are inside the Rails application, the GitLab Rails application, those are inside Puma, and we have covered that by enabling support for TLS in Puma in general. And then there are the dedicated server endpoints for Puma and Sidekick, where this is the last remaining thing that we're working on, where we also want to enable TLS security. Our third priority is to create custom SLIs for global search. Global search is this amazing feature we have in GitLab that allows us to search over almost everything that is searchable. So at the moment, and this is, so let's say memory. So if I search for memory here, I can search over epics and code and issues and merge requests. I can check, for example, references to memory on all over the place inside GitLab or the GitLab organization, or I can go to merge requests and whatever. So the problem here is that at the moment we gather those metrics in aggregate. So all those types of searches are accounted as one type of metric. We want to increase our visibility, and we want to differentiate between those types of searches and have a different metrics, gather different metrics inside the application, expose them to different Prometheus metrics, and finally build SLIs and SLOs for those metrics. And the idea there is that we want to differentiate between basic and advanced search, because those are completely different. If advanced search is a premium feature, if it is enabled, that means that the queries go to Elasticsearch instead of PostgreSQL, and those are completely different. Those have different characteristics, and of course, to differentiate by scope, where, for example, searching over merge requests is completely different than searching over commits, for example, which goes over, those are Git commits. So in 15.2, we will continue our work on adding those custom SLIs and SLOs. And our final two priorities to revisit our work on optimizing workers that consume a lot of memory and cause out of memory kills. So in the past, we have investigated some issues and have found that there are a few workers that consume a lot of memory, more than some of them, more than 1 gigabyte of memory, and even 2 or 3 of them more than 5 gigabytes of memory in some cases. And I'm talking about one worker, one job running for this specific worker. In general, we don't want any workers to go above 100 or 200 megabytes. So all those workers are problematic. So in the past, we have addressed the most hungry ones. And the reasons, the fixes were, for example, we had some issues with parsing of coverage reports that was taking too much memory, and we reduced it by more than 80%, or while sending email notifications, when generating the email from the templates, if the notification had tens or hundreds of comments reported at the same time, that will consume a lot of memory. Or we have fixed other problems with N+1 queries on some controllers. We want to go back and investigate other similar workers and optimize them. So that's it for 15.2. Thank you for watching, and talk to you next milestone.